we're going to talk about angle, side, angle, and angle, angle, side. So we've discussed and we've quizzed and we've assessed side, side, side versus side, angle, side. If we're proving side, 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 what three congruent pieces do we need to show? Three congruent sides. And if we're talking side, angle, side, what three congruent pieces did we need to show? And what was it? So two congruent sides and a congruent angle, but what was important about that angle? That it was included between our congruent sides. Otherwise, we can't use it to prove congruence because that's our donkey theorem. Donkey theorem does not prove congruence. So when I tell you angle, side, angle, what three pieces do you guys think we're going to need? Two angles and one side. And what do you think is going to be important about that congruent side? Yep, so two congruent angles and one congruent side. So when we're trying to use angle, side, angle, just like side, angle, side, where the congruent angle needed to be included, our congruent side needs to be between our congruent angles. So if two angles and an included side must be included to do side, angle, side. Two angles and an included side of a triangle are congruent to two angles and an included side of another, then our triangles are congruent. What are our congruent pieces here? If A is congruent to, can't write in highlighter, dummy. Angle A is congruent to angle D. And segment AB is congruent to whom? DE, good. And then angle B is congruent to angle E. So if we do our little highlighter trick, so we've got our congruent angles A and D. We've got our congruent sides, AB to DE. I don't like it. AB to DE. And then our other pair of congruent angles, B to angle E, is our green congruent side touching both of our congruent angles. Yes. So our congruent side must be touching both of our congruent angles. No, but it's just the next one we're going to learn. So if as long as our congruent side is touching both of our congruent angles, then our triangles are congruent. So triangle ABC is congruent to triangle DEF. Wow. By what? Angle, side, angle. And again, the name tells us what we want. Where's the S at in the name? It's in the middle of the A's. So guess where the side needs to be in the triangle? In the middle of our angles. If they're not, it's the other one we're learning today. What's up? All right. So remember, included means between. So now instead of between the included sides, it's going to be between the included angles. The side between the angles. Let's fix that. Side between the angles. All right, SQ bisects RQT and RST. What does it mean to bisect something? Cut in half. So what if if SQ is bisecting this angle, what does it do to those other two angles that it creates? They're what? So if they're bisected, they're what? Congruent. Good. So they're cut in half. So
wait, if it's always cut in half, that means always going to be congruent?
yep,
Always?
every time. So RQS is congruent to TQS. Okay. And the same thing is created on this other angle. If this segment bisects this big angle, what does it do to those two smaller angles? Cuts it in half, and when it cuts it in half, it makes it into two congruent angles. Yes, sir.
I have a question about this one. How do you know if it's a segment or an angle?
What did we cut? Did it cut an angle or a side? It's an angle bisector. Yeah. All right. So, how did we know the SQ bisects our two angles? Good. They told us. How did we know RQS is congruent to TQS? How are we able to draw on our diagram? So what did we use to know that? What did we use from the step before? A bisector. So if we're using something, we call it a what? Definition of it. I'm listening. Why would it be definition of congruence? But so fight for the real, why would you think it would be?
Because both sides are cut by a bisector.
So when we use definition of congruency, what do? It allows us to go from congruent to equal or equal to congruent. Is that what we did right here? No. How are these two angles created? They were cut by the bisector. Good. Number 3, how do we know RSQ and TSQ are congruent? What allowed us to make that mark on our diagram? What's that? So let's go to our picture, RSQ and TSQ. If we go to our picture, it would be this angle and that angle. What created those two congruent angles? Yeah, that SQ is the bisector that created those two congruent angles. So again, it's definition of angle bisector. QS is congruent to QS. Why? Shared side. Reflexive property because it's a shared side. What's up? So that's one of our shared sides. And a shared side is always congruent. So how can we say our triangles are congruent? Angle, side, angle. If we want to use angle, side, angle, what's important to have? The side is included in our congruent angles. So if I take and I do my highlighter, and I just highlight what we know as to be true, is the blue side between our congruent angles? Is the blue side touching both of the angles? Yes. Now another thing I want y'all to remember, it's one triangle at a time. So we look at this top triangle by itself. Does our blue side touch both congruent angles? Yes. Then we look at our bottom triangle. Does our blue side touch both congruent angles? Yep. So then that's what allows us to say angle, side angle. Any questions? All right, let's go to the next one. Oh, baby, parallel lines. What do we know about parallel lines? If I see a parallel line, it should trigger what in my brain? Yeah, alternate interior, alternate exterior, or corresponding. That should just go, oh yeah, something's in there. So it says JL is parallel to KM and, or LM, sorry. What? Oh, I did both. And then LM is, how come I use double arrows instead of single arrows on that one?
Because it shows that it's not congruent to the other.
We're showing that it's not necessarily parallel to the other ones, even though we're not stupid, right? We know that it's not. All right, so when we're doing this, I want you guys to look for the Z. So if we're doing alternate interior angles, it will always form a Z. So if I take JK and try to draw a Z using that segment, what do I know about the corners of my Z? That's where my angles are congruent. So JKL is congruent to MLK. Yep. And we can do the same thing for our other pair. Draw our Z. Just the backwards. What do I know about the congruent angles in my Z? Are the, dang it, the corners of my Z? What does the corners of my Z do? Creates congruent angles. So we know those two are congruent. Is there anything I want to mark up before we get to our proof? Anything else? What side? What do we know about it? It's congruent. Good. All right, let's see what we got in our proof. How did we know that our lines were parallel? It gave it to us. If they did not tell us, we could not assume. So what allowed us to say JKL was congruent to MLK? What allowed us to say our red angles were congruent? Alternate interior angles. Yeah, man. Did it tell us they were bisected? Then we can't use bisector. And then if it was bisector, our light blue and our red would be the congruent angles, not the opposite. Okay? What allowed us to say our light blue angles, JLK and MKL, are congruent? Same thing, alternate interior angles. So both, if we look at our diagram, the light blue line on top, so JL, light blue line on bottom, KM, those two are parallel. So, yeah, so if these two lines are parallel, being cut by a transversal, sides, angles that are on opposite sides of the transversal and inside of my parallel lines are my congruent angles. Yes, sir. Okay, how did y'all know KL was congruent to LK? Why? Shared side. It's our reflexive property of congruence because it's a shared side. Oh, Peter. All right, JKL is congruent to MLK. What do we know? How do we know that? Angle, side angle. So if we were to go back to our picture and highlight what we know, so we've got those two red guys are congruent. These two green guys are congruent. And the line down the middle. Remember, we look at this one triangle at a time. In my top triangle, is my yellow side touching both of my congruent angles? Yes. Bottom triangle. Is my yellow side touching both of my congruent angles? Yes. So that's what allows us to go angle, side, angle. Any questions? Thoughts, concerns, prayer requests? All right. We're going to skip the next one. And we're going to go to angle, angle, side. So we've learned three. Side, side, side. What do we need to prove? What three parts? Three congruent sides. Side, angle, side. What do we need to prove? And what's important about that angle? That it's where my two congruent sides come together, that it's included. Angle, side, angle. What three parts do I need? Two congruent angles and one congruent side. What's important about that congruent side? It has to be included, touching both of my congruent angles. So when I tell y'all angle, angle, side, what do y'all think? Two congruent angles, one congruent side. And what do you think is the difference between angle, angle, side versus angle, side, angle? The side is not included. That's the difference. And this guy, the side is not included. So our side is not going to be between our congruent angles. It's only going to be touching one of them. All right, here we go. So if A is congruent to D, and angle B is congruent to angle E, excuse me, and then our side that's congruent is now BC is congruent to EF. So when I go and mark up our diagrams, nice and pretty like, so A to D, B to E, and then my side is BC to EF, is my congruent side between my both congruent angles? Is it touching both? It's only touching one. So that's what makes this angle side, angle side. So ABC is congruent to DEF, and it is angle, angle, side. So it's non-included, the side that is opposite the angles. So it's not touching both, it's only touching one. So let's go ahead and mark up our diagram with what we know. It says YZ bisects WYZ, or WYX. So this segment bisects those two angles. What does it mean to bisect something? Cut in half. So it's going to make our two angles congruent. What else did they tell me in the given? So YWZ, so remember it goes Y to W to Z, is congruent to YXZ. All right, and then there's any other piece of information that we can write in that we know is true?
Side.
What side? The bisector is what? It's congruent, yep. Why is it congruent? Why? That doesn't mean anything. No, why is it? Nope, why is the side congruent? You do know. We've used it 3 times today already. Nope. We've used that same property 3 times today, guys. It's reflexive. It's a shared side. All right. So how did we know that YZ bisected and that those 2 angles were congruent? Given. Oh, I put both of them on one line. That's all right. And our next one is also the given, right? Wait. No. What's the next one? Definition of angle bisector. How come? Nope. Why is this the definition of angle bisector? But why is it cut in half? Because it bisected it in the previous statement. So we used our bisector to prove that it cut it. What's the next one? Nope. It's part of our what? It's part of the given. Why is YZ congruent to YZ? Hey, stop. Reflexive POC, good. Why is it reflexive? Nope. Shared side. Shared side. Okay. So when I look at my diagram, is my yellow congruent side between my blue and green congruent angles? No. So which one are we using this time? Angle side. I'm listening.
The 2 green ones up next to the line.
Yep.
Those are angles.
Right, but what do? When we look at them at what? One at a time. Is that yellow side between the congruent angles? No. And then I look at the other one the same way. Is that yellow side between the congruent angles? No. Yeah, I know. That's why I'm being very specific about one at a time today. Because you're not the only student that'll do that, and you're not the only student that won't do that in the future. Okay? So guys, remember, we look at it one triangle at a time. In one triangle at a time, even though that yellow one is between both of the greens, it's one triangle at a time is the yellow between the angles. For blue and green. No. One triangle at a time is the yellow between the congruent angles. No. So that's why it's angle side. All right, let's do one more, then I'll set you free. So let's go ahead and mark up our diagram with what we know. It told us ABC is congruent to CED. So these angles up here are congruent. It tells us AB is parallel to CE. So when I see that, I automatically need to start thinking what? Alternate interior, alternate exteriors corresponding. Automatically, when I see parallel lines, I need to think that. And then lastly, C is the midpoint of AD. So what does it mean that C is the midpoint of this segment? What does it mean to be in the middle? Makes 2 congruent sides. Good. Yep. How did we know that ABC was congruent to CED? Yeah, they told us. How about AB is parallel to CE? Yeah, they told us. What about C being the midpoint? Yeah, they told us. Half our problem's already done. So what made AC congruent to CD? Why?
Because it's a midpoint.
From 3 to 4, what changed? We went from what? Them telling us it's the midpoint to us proving that it's the midpoint. So yeah, guys, definition of midpoint. You did. I'm proud of you, dude.
Thank you.
All right, now BAC is congruent to ECD. So BAC is congruent to ECD. What? Oh, I need to do 2, don't I? What do you guys think? So we've got our parallel lines. Our parallel lines are cut by a congruent segment. What do you think? Opposite sides of their parallel line, same side of the transversal. What do we call that? Corresponding. I don't know if that's the ones I would have went with, but that's the one the worksheet went with, so we're going to go with it. I'm not going to criticize it. Okay. Corresponding angles. And then lastly, angle, angle, side, or angle, side, angle. AAS. Why?
Because there's 2 angles, and one side they're not connected.
They're not between it. Good. All right.